Welcome back to Rust Coding Challenges. Today a valid parenthesis, lead code number 20, one of the most common warm-up questions in interviews. You're given a string made only of brackets, round, square and curly, and you have to decide whether they're balanced. Every bracket closed by the matching type and in the right order. It sounds fiddly, but there's one data structure that makes it fall right out, a stack. Let's build it in Rust. Here's the setup. The string contains only brackets, three kinds, round, square and curly. It's valid if every closing bracket matches the most recent opening bracket that hasn't been closed yet. So round, square, close, round is fine. The inside pair closes before the outside one, but round, square, close, square is not, because when the round tries to close, the most recent thing still open is the square, not the round, so the order is wrong, and it's also invalid if you reach the end with something still open, like two opening rounds, and nothing to close them. The key phrase is most recent, and that's the clue. Here's the whole idea in one picture. We keep a stack, a pile, where the last thing you put on is the first thing you take off, like a stack of plates. We read the string left to right. Every time we see an opener, we push it onto the pile. Every time we see a closer, we pop the top of the pile and check it is the matching opener. Watch it on round, square, close, round. Round comes in, push it. Square comes in, push it. Now the pile is round, then square. Close square, pop the top, it's a square, match is good. Close round, pop the top, it's the round, match is good. The pile is empty at the end, so it's valid. Now the tricky one, round, square, close round, push square, then close round pops the top, which is a square, not a round. Mismatch, invalid immediately. The stack automatically remembers the most recent opener, which is exactly what the rule needs. Let's build it. The function takes the string and returns a bool. We set up an empty stack, a vector of characters that holds the openers we've seen but haven't closed yet. Then we loop over each character with a match, empty for now, and at the very end we return whether the stack is empty, because anything left over means an opener was never closed. Let's fill in the match. And this is the whole algorithm. If the character is any of the three openers, round, square or curly, we push it onto the stack. If it's a closing round, we pop the top of the stack and check it's an opening round. If the pop gives anything else or the stack was empty, we return false right away. Same for closing square and closing curly, each must pop its own matching opener. Anything that isn't a bracket we just ignore. Notice, pop returns an option, it hands back the top if there is one, or nothing if the stack is empty, and comparing it to some of the opener handles both the wrong match case and the nothing to close case in one line. That's the Rust touch. Let's run it on 6 cases. A single round pair is true. Round, square, curly all closed in order, true. Round then closed square is false. Mismatched types. Square nested in round is true. The interleaved one, round, square, close, square is false. The order is wrong. And 2 open rounds is false. Nothing ever closed them. Every case correct in one pass over the string. Why a stack? Because the rule itself is a stack. Most recent opener closed first is last in first out, which is the definition of a stack. Pushing every opener and popping on every closer means the top of the stack is always the opener that the closer must match. If the pop is the wrong type, the order was violated. If the pop finds nothing because the stack is empty, there was a closer with no opener. Both are failures, and Rust's option type lets us catch them in a single comparison. And if we finish the string with a non-empty stack, some opener was never closed. Match the top or fail, empty at the end or fail. That's the whole thing. Quick recap. To check balanced brackets, use a stack, walk the string once, push every opener, and on every closer pop the top and make sure it's the matching opener. If the pop is the wrong type or the stack is empty, it's invalid right there. And it's only valid if the stack is empty when you're done. It's one linear pass and the stack does the remembering for you. Whenever a problem involves nesting or most recent first matching, brackets, tags, undo history, reach for a stack. A quick note, breaking these algorithms down in Rust line by line takes real work. If it helps you, the wallets are on screen and there's a Ko-fi link below. Every tip funds the next one. Thank you. That's valid parenthesis, solved with a single stack and one pass over the string. It's the pattern behind a whole family of nesting problems. Subscribe so you don't miss the next challenge, tell me in the comments which problem to break down next, and I'll see you there.